All right, so here we are. We're taking a look at some Mach number questions. And for number one, you do need to be able to convert units using unit analysis from meters per second into the units here are kilometers per hour. Okay, you guys can see that? So question number one, it says, what is the Mach number of an aircraft traveling at sea level at 0 degrees Celsius, there's our temperature, with a speed of, let's talk about A first, 1,440 kilometers per hour. Well, our formula, which is 332 plus 0.6 times the temperature, we know that. That's the speed of sound, right? In meters per second. That is in the different unit than what we have here. So let's first of all find the speed of sound here at 0. Well, that's easy. 332 plus 0.6 times 0. That's 332 meters per second. Now, I need to convert meters per second into kilometers per hour. So if you remember how to do that, this is the first step. 332 meters per 1 second. We need to multiply to eliminate the units we don't want. So I don't want meters. So you're going to multiply with meters on the bottom. So these divide out, cancel out. I do want kilometers. So do you know the relationship between kilometers and meters? Of course you do. This is 1,000 meters is 1 kilometer. So you make that a multiplier, okay? You multiply that. And this is, again, unit analysis. So right now, if we were to do 332 divided by 1,000, that's kilometers per second. I do not want kilometers per second, so I need to get rid of seconds. Let's put seconds up there. I need hours. Well, if you know how many seconds are in an hour, you can go ahead and do this. If you don't, then do something you know, like seconds to what? You know how many seconds are in a minute. Okay, fine, minute. There's 60 seconds in 1 minute. Okay, great. The seconds are gone. What do I have right now? I have kilometers per minute. Still not what I want. That's no problem. We just keep multiplying until we get rid of the units we don't want. So I don't want minutes. I want per hour. We know the relationship between minutes and hours. That's 60 minutes is 1 hour. So there we are. We are now poised to make our conversion. And again, this will take you a fraction of the time it's taking me because I'm explaining this. So once you get this down, you'll be able to figure this out pretty easily. And actually, there would be a shortcut after you figure this out once. You're going to know what the factor is, what the actual number is to go from meters per second to kilometers per hour. So you don't have to do this really every time either. So what are we going to do? 332 times 1 times 60 divided by 1 times 1,000 times 1 times 1. So that's going to be 332 times 60 divided by 1,000. All right. So what is that number going to be? Get my calculator up here. Turn it on. 332, because that's the speed of sound at 0, times 60 divided by 1,000. And that's going to be 1195.2. Okay, 1195.2. And what's that going to be in? Kilometers per hour. Okay. Now, what is it here? Remember that shortcut I told you about? So what is it that we multiply the speed of sound in meters per second? What is it we multiply by to get kilometers per hour? Well, it's this right here. It's that right there. So if we're talking about a shortcut, guess what? 60 times 60 is 3,600 divided by 1,000. That's actually 3.6. So guess what? If I did meters per second times 3.6, I get kilometers per hour. That's using your brain right there. So from now on, if you need to convert from meters per second to kilometers per hour, you know, because of what math tells us, and math helps us, is that you multiply by 3.6. That's what you do. That's the factor. Okay. So that's a little tidbit for you for later. Okay, there you go. That's important. You want to write that down because I'm going to erase it. Boom. Why? Because I need to finish this question. So we're not done yet. Okay, so Mach number. So the Mach number is speed of an object divided by the speed of what? Sound. Right. I know, it's early. So the speed of the object, what is this? Is this speed of the object or is this speed of sound? So speed of sound. Well, object is here. So it says the Mach number of an aircraft at this speed. 1440. So that's the speed of the object is 1440 kilometers per hour. Nice. And the speed of sound here in air at 0 is 11 95.2 kilometers per hour. Awesome. The units are the same. I simply do this division, and then I'm done stating the Mach number. So 1440, wow, not 6440. Where did 6 come from? 1440 divided by the answer that I had there already. So there we go. 1.2. Look at that. So Mach 1.2. So is this aircraft traveling greater than the speed of sound? Well, yes, it is, because 1400 is greater than 1195. And the Mach number is greater than 1, right? So Mach 1 is the speed of sound. Anything above that is faster than the speed of sound. All right? Any questions about number 1? Okay, well, let's do number 2 then. Okay, so here's the final answer for number 1 from before. Number 2, I think I have number 2 started up here somewhere. So let's take a look at number 2. Obviously, speed of sound is 332 plus 0.6 times the temperature. What does this question say, though? A military interceptor airplane can fly at Mach 2, 2.0. What is its speed in kilometers per hour at sea level and 0 degrees Celsius? Well, from question number 1, we know what the speed of sound is at 0 degrees and, yeah, sea level. We won't worry too much about that. But so Mach number is the speed of object divided by the speed of sound. And so we have 2.0 is the Mach number. So I'm going to put that right there in my equation. I also know that the speed of sound in kilometers per hour at 0 is 1195.2, right? So guess what? All I need to find is this unknown value right there. And that's pretty easy. It really doesn't get much easier than that. I'm going to cross multiply or multiply both sides by 1195.2. So if this is the speed of sound at Mach 1, what's the speed at Mach 2? Times 2, right? Really easy. So I do 1195.2 times 2, 2390.4. So x is 2390.4. And what units are those? Let's see, kilometers per hour. Right? Because remember, this was kilometers per hour, and this was no units. So x is going to be in kilometers per hour. All right. Those are the answers that I get for those 2 questions. Anybody agree or disagree? Yes? Okay, thank you for that question. Significant figures. Significant figures. So for significant figures, yes, you would consider significant figures. I'm kind of, this maybe sounds bad, but I'm kind of moving a little bit past worrying too much about significant figures. But if you're wondering what your final answer should be like, how many decimal places, that's what you go back to. The reason why I'm kind of moving past concerning myself too much with significant figures now is because the textbook and the different things we're going to use are not consistent, okay? So they will give a measurement in 1 sig fig for this big question. It's like, well, they didn't really mean that. You know what I mean? Like, so for this one here, yeah, if you're wondering at all, I'm okay with this. I'm okay with your lots of decimal places because what I'm concerned about is that you're doing the calculations properly, okay? The precision, I'm going to kind of overlook a little bit now, okay? But yeah, so let's see. Good question, though. Number 2, so what do we have? We're given 2.0. Now, someone might say, well, Mr. Maxwell, 0 degrees Celsius, that looks like 1 sig fig. So can my answer only have 1? See, that's the problem, okay? That's the problem. If we move this to 1 sig fig, like this measurement apparently is, then our answer would be what? 2,000. That's a pretty big difference, isn't it? So, you know, do you use 2? Maybe you use 2. But again, I'm not going to worry about that so much. Question? Yeah?
But isn't just a regular 0 not a sig fig?
Well, that would be rounded to the nearest whole number. Yeah. So 0 as a number is still a number. Yeah. Yeah, because it could be 0.0. It could be 0.00. And in that case, there's no non-zero digits. So those rules don't really apply because there's no non-zero digits to refer to. So yeah, it's a good question though. Good question. Is it a placeholder? No, it means 1 number. Okay. Anybody else? These are great questions. Okay? Good job.